Okay, guys, welcome to our session 5, and we're going to be looking at chemistry this time around. Um, Guys, let's do something very fast. Can you quickly give me answers to the first four questions? I hope it's big enough. Those of you at home, is it big enough? Is it visible enough? Just let me know if it's visible enough, yes or no. Let's see if we can spend 15, 20 minutes multiple choice. Thank you, Magdia. All right. Guys, you have four questions, and I'm giving you just 5 minutes. Uh, time is important. I'm going to smack you, Dash, with that B of yours. All right, 5 minutes, I think we can, or let's say six. Quickly. If you are all done, we just say done, 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 so we don't waste time. Guys, by the time I hear green, 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 you must be done with answers, please. I also thought there were four. That's why I gave 6 minutes. I thought there were four questions. But this one, there are four of them. You can try to see. So, would you rather go, because you have to draw, you want to be fast, you rather go with the paper full of errors? But there's no Kaloku here. No, there's no Kaloku here. Child, I have shown you several, okay, maybe not you, but people here know that even if I don't finish the paper, I can get a level 6. No, five was without a rate of reaction. Five was without rate of reaction. Because hold on, Yeah, 5 was once you add rate and you add chemical equilibrium, you definitely move to a 6. Guys, people here are saying the answer is always B. I don't know where they got that from. I never thought. Disclaimer: Bishop never taught that. Disclaimer: Bishop never said that. Disclaimer: It never came from crazy physics. Underlined. It is one girl here that said answer is B. One girl. Hmm. Rashford face to face, just like the other one. Okay, let's mark. Which one of the following is a tertiary? It's B. Ne? B. Oh, so the one you don't know is B. Guys, what's the answer to number one? How? Okay, guys, butan 1 all is a primary alcohol. Propan 2 all is a secondary alcohol because the carbon atom is now surrounded by what? 2 carbon atoms. I'm looking at 2 methyl butan 1, or that would be my first option. And what I can see quickly do, somebody's complaining about time here. Yeah, please. Just draw very fast. You don't have, don't, the time, it will take time if you're using a ruler to draw. But if I just draw in CCCC, that thing doesn't take time. Except you take a ruler, you are measuring. That's what it takes time to draw. 2 methyl butanol, butan 1 all. 1, 2. You don't even have to draw all the hydrogens. Ta 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 ta. Now it says 2 methyl on carbon number 2. There's another carbon here, right? Ta ta ta. And butan 1, which means on the first what? Carbon. C it's not even C. Wrong. Because this is connected to this and this is connected to 1. Already it's not A, it's not B, it's not C. Can we confirm D? Okay, it's prop. Do you see that it's not taking you time to draw, but your answer is certain? All right, we have propanol. Propan 2 all. So it's sitting on carbon number what? 2. And there's a methyl group here. Lovely. So the carbon atom that is attached to the OH, it's attached to what? 3. That is what? D. B. 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 B for Bishop. B. Wrong. 1.2 is B. Okay. We consider the following. All right, we have those there. Which one of these are what? Chain isomers. What are chain isomers? Organic compounds with the same molecular formula but different what? Chain length. Is that okay? Chain length, not with chain strength. If you are going to be the end of me today. Thank you, guys. Those that said G. But let's see this one quickly. Chain length. You know what I would first see quickly? Because I want to save time. I'll see if I can quickly count the number of carbon atoms. That's what I want to check first. All right, the first one. 1, 2, 3, 4, 5, 6. C6. Just to check quickly. C6. 3 plus 1, 4. Plus 3, 7. Plus 1, 8. Plus 3, 10. 3 plus 1, 4. Plus 3, 7. Plus 1, 8. Plus 11. Okay, 14 plus 3. Is it 14 plus 3? 11 plus 3. 14. I'm tired, guys. I've been my third lesson today. Dash, after teaching you for 3 years, you are ganging on me right now. Okay, it's fine. I'll see you when you get to varsity. 1, 2, 3, 4, 5, 6. C 6. 3 plus 2, 5 plus 2, 7, 8, 9, 10, 11, 12. All right, I'm already seeing that. Do you notice something there? If they are isomers, they must have the same what? Molecular formula. Let's try 3. 1, 2, 3, 4, 5, 6. Also what? C6. 3 plus 2, 5 plus 1, 6 plus 3, 9 plus 2, 11 plus 3. All right, so we're looking at 1 and 3 most likely. But let's check first. What about the last one? 1, 2, 3, 4, 5, 6. There are 6 of them. There's a 2 there. See what? 6. 3 plus 1, 4. Now 3 times 2, 6 plus 4. Do you see? We didn't even need to draw. 1 and 3. B, 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 B. B for bishop. All right, guys. But guys, is what I did making sense there? All right. 4 mile group. Can we draw 4 mile group? 4 mile is what? CHO, which is C, that, and then, and where would you find that? Aldehyde. What's the answer? C. Imagine this page had no B. Okay, but guys, are we okay with the multiple choice? Makes sense. Chemistry multiple choice is a lot better than the physics one. It's a lot better. So please, uh, this looks too tiny. Let me do something here. Guys, please, I want us to move very fast. Otherwise, we won't cover quite a lot today. 1.4 and 1.5. Let's start working. 1.4 and 1.5. I'm just going to get a mouse to. What happened to what? It's very easy. It's so nice. That's a free mark. That's easier than spelling your name. I promise you. Guys, start answering. My mouse is not working. Okay, now it is. If I notice. No, my mouse will not disappoint me. Evil people. All right, there we go, guys. Quickly, let's give ourselves 3 minutes here. 3 minutes, or because there's so many readings to do, 4 minutes. Quickly, 2 minutes for each. Ah, no, there's too much time here. A piece of magnesium ribbon reacts with excess hydrochloric acid according to the following equation. All right, which one of the following changes will not affect the rate? Before we answer this question, guys, what are the factors that affect the rate of reaction? There are six of them. Okay, can we quickly list the six of them? Quickly, tell me what you remember: concentration, pressure, temperature. Start from those three. Next, surface area, catalyst, and the nature of what? Reactants. So we said concentration, pressure, temperature. There are six of them. Which one of them will not affect? Check. Putting the mixture in hot water, that's temperature, it will affect. Using the same mass of powdered as compared to ribbon, this is surface area, it will affect. Increasing the volume, there's nothing that has to do with volume there. My answer is C. Increasing the concentration, do you notice concentration is also there? Check how easy it is to answer your question. This, like I said, you can do a lot of this even during multiple, during your reading time. Get your multiple choice answers. Which of the following is correct about chemical reaction at equilibrium? The examiner is asking you to define chemical equilibrium here. And I always give you two definitions if you remember. The rate at the state where the rate of the forward is equal to the rate of the reverse. It's also the state where the concentration of reactant and product are constant. You must know that. The concentration of reactant and product are constant. What's the answer? A. Unfortunately, okay. Guys, are we okay? All right. Please take note of that definition there. Is that okay? Take note of that definition. Um, 1.6. Ayabunga, this is for you. Let's make it bigger. Maybe B means bigger. It's B. Guys, what's the answer to this one? 1.6. Let's listen to those at home. Guys, the fact that sulfur is appearing there is wrong, right? Because it's a solid. Automatically, I know that these two are wrong. A is wrong. The other one is wrong. C is wrong. Sulfur must not appear there. All right? Uh, is it B for Frederick says B for Bishop. Product over that of what? The reactants. Okay, correct. At least your B only got you two of out of 20. 2 over 150. B. Okay, quickly. This one. 1 minute here. This one, we're not wasting time, please. 60 seconds. Please get me answers. 60 seconds. You have 19 seconds left, though. Okay, give me answers. 1.7. According to Arrhenius, the H there, you see that thing? ARRH tells me there's water. That's what I use. And if it's a base, it must form hydroxide what? Ions. The correct answer is what? D. Consider the following reaction. Which one of the following are two acids in the above? All right. What is an acid? An acid is a proton what? Donor. This is an acid. Because if I compare this and this, I see that there's 3 here, there's 2 there. This one has gone this way. So this is an acid, and that is a base. When an acid donates a base, it becomes, when an acid donates a proton, it becomes a conjugate what? Base. So when H3PO4 releases a proton, it becomes a conjugate what? Base. And when a base accepts a proton, it becomes a conjugate what? Acid. Which ones are my acids? H3PO4 and H2CO3. C. I really like this option B. I love option B. All right, the last two. You need your tables, guys. No, why 3 minutes? Guys, please use your tables. Yes, Steps, your hand is up. Sorry. Okay, hold on, Steps. Sorry, guys, can I please hear what she said? Yes. Yes, Nana. Okay, all right. Let's answer this one, then we'll go back to that question. Okay. All right. Do we have answers already, guys? A galvanic cell is constructed from cadmium and nickel. Which one is the correct notation? Please just check your 4B tables. Don't worry, you'll get it before you don't even need a video. You'll get it today. All right. check your table. There's a table I passed across there. Okay, just 1 second, guys. I'm just quickly sorting out something here. But in the meantime, please share your answers, those of you online. Share your answers with me quickly for 1.9. 1.9, Jelin and Dash. 1.9, Frederick says C, Regan says C, Ricardo says C. All right, okay, thank you, Magdia. You also say C. So what you do is you check your table, right? Which one do you find first? Is it cadmium? Cadmium is CD. And then you have nickel. Which table are you using? 4B. 4B table. Which one do you find first? Okay, guys, I'm giving you this. Everyone should have a table. I want you to share so that you have your own answers. All good? All right. Guys, we just go and check on the table. Is that okay? The table. I hope everyone has a table there. Which one is on top? Cadmium. All right, so it means cadmium would be the anode. Okay, so for you to write a cell notation very well, it's going to be the anode here. What's next? The bridge. Remember what we used to say? It's as simple as what? A, B, C. Okay, how do you represent the bridge? 2 strokes. Side, we are going to have the reactants and what? The product. On this side, you're also going to have what? The reactant and the product. But one thing we know, it must start with a solid and also what? End with a solid. Solid on the left and solid on the right hand side. So it must be solid there and it must be solid there. So if I check my table, you said which one is on top? Cadmium. And then which one is at the bottom? Nickel. It means this is my anode and the cathode. Already there's a problem here. That's supposed to be a solid. Wrong. B. Nickel is the reduction. That's the cathode. It's supposed to be on the left hand side, right? So, because our anode is supposed to be on the left. A, B, C. That's wrong. What about C? Cadmium. Anode is a solid. A solid. Correct. And the correct answer is what? C. Aya, you're going to get this today. Don't worry. I'm not going to allow anyone to lose marks on this. No, cannot. These are the topics where a learner must get what? 100. Which of the following half reaction takes place at the cathode? What happens at the cathode? Reduction. Can I quickly tell you something here, guys? Please watch this. When it's the cathode, I'll do that when I want to look at electrochemistry. Of an we are electroplating an iron spoon with what? Silver. It means silver must be formed. Is that okay? Silver must be what? Formed. For we to have silver, we're going to have what? Ag plus E plus what? Ag. Which one is correct? For those of you that were choosing B, 2/20. Wow, lovely, nice. But they said it's physics. It's chemistry. Okay. Well done. Guys, we are quickly going to support each other. No one should be losing marks on electrochemistry. Is that okay? No one. It's a no. But before we get there, all right, guys, let's run quickly on this question. As fast as you can. Can I give you 10 minutes? I want you to get all these marks. 10 minutes. Please, no talking. Let the time, you know, put you under pressure. 10 minutes. 10 minutes. It's not the same paper. All right, let's answer. I hope everyone is done. Guys, again, we should get good marks here. Is that okay? The first thing I see, alkane, my butane is an alkane. And what's the formula? C4H10. It's an alkane. CnH2n plus 2. It is an alkane. These are the things I'm quickly going to write there. What about B? I think B, the best thing is to draw. Is that okay? The best thing is to draw for B. What would I draw? It's CH3. Is that fine? Then what? CH2. Then there's a C. There's another C. Then there's a CH3. Look, before you start playing around with the bonds, just do what I did first. Then now start checking around the carbons. Carbon number 1 is fine. Carbon number 2, is it fine? Yes. Carbon number 3 and 4 is a problem. All right. Is it okay? No. Is it okay now? Yes. And every other thing is fine. Once you draw, check how simple life can be. Make sense? All right. What's the name of this compound? 1, 2, 3, 4, 5. It is what? Pent 2 what? Ine. It's an alkyne. General formula CnH2n minus 2. What about C? Longest chain. Longest continuous. Guys, that's my longest continuous chain. Is that okay? If you don't see that already, the name is wrong. The one that is not inside the box is a side. 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 Right? Okay, so it's a haloalkane. How many carbons are on the longest? 1, 2, 3, 4, 5, 6, 7, what? 8. But let's check. If I start from here, 1, 2, 3, this will be carbon number 4. This will be carbon number 5, right? And this will be carbon number 6. I'm writing the ones that have my attachments. What if I start from here? Let's use a green one. This will be carbon number 3, carbon number 4, carbon number 5. We've got to use the one that is the smallest. Which one? Is it the red or the green one? The green one. Are we together there? All right. So for the green one, what do I have? I have 3 chloro. What else? I have 4 methyl. And I have what? 5 what? Chloro. I write that out quickly first to see. It must be arranged in alphabetical what? Order. C comes before what? M. So what should I have? 3, 5 di chloro dash 4 dash methyl what? Octane. Are we okay there? All right. Please let me know where you are confused, because I think I am just moving on the table and I'm already answering a lot of questions there. Okay. What about D? D is a ketone. And what is this called? The functional group. It's called a carbonyl. Please. Under our multiple choice, we did the aldehyde, which is called a formyl. Is that okay? What is the name of this compound? It's 3 of them. So it's what? Propan 2 on. Propan 2 on. Are we okay, everybody? And the 4th one is what? A carboxylic what? Acid. What's the functional group? It's a carboxyl group. And what's the formula of that? COOH. Can we now answer our questions? A compound with a general formula CnH2n minus 2. B. A ketone. G. A compound that can be used as fuel. A. In case you didn't know. Alkanes can be used as fuel. So let's take note of that. Unsaturated hydrocarbon. Really? Why A? Unsaturated. All right. Compound E. Write down the name of the functional group. I think I did already. What is the name? Carboxyl group. Structural formula of its functional what? Isomer. What is the functional isomer of carboxylic acid? Esters. That we must know. Esters. Esters. Uh, we have an acronym for that. What's the acronym? For a function, you need what? A cake. Okay? Don't worry, you'll be fine, child. Okay. You'll be fine. You've got work to do. They're too hungry and they're mentioning cake. All right. Guys, for a function, we said we need what? Cake. And what does your cake stand for? Aldehyde and ketones, carboxylic acid, and esters. Now they said butanoic acid. How many carbon atoms? 4. Can we then draw an ester? There are about 3 answers to this particular question. I have butanoic acid and I want to draw an ester, which is a functional what? Isomer. All I need to do is to remember the functional group of the ester first. Right? And then what do? I distribute the. Already I have 4. I'm done here. This is 1. You agree, guys? There are 4 carbon atoms. 3. Okay, let me add the last one here, which gives me what? 4. Time around, I have 2 on the left, I have 2 on the right. We're going to name these compounds. Okay? Can we try another compound? I have that. 1, 2, 3. That's fine with you. Again, do you see that I still have my COOH, right? COO rather, that's the function. The functional group of esters is this. That must be there. Once I see that, I'm talking about an ester. What else can I have? I could have so many other. I could have 1. Yeah. There we go. As long as the number of carbon atoms now, there are 3 different answers. We name them. How do you know? I name my own ester. I look at the oxygen. I divide it into 2. Is that okay? I break my compound into 2. Everywhere I see oxygen. Now there's a double bond somewhere. The double bond represents the carboxylic side. The double bond represents what? The carboxylic side. And when I want to name, I'm going to start from the alcohol side. How many carbon atoms there? 2. Ethyl thanoate. Let's name that one. Start from the alcohol side. How many carbons here? 3. Propyl and what? Something just came to my head now that could help you. Right? It's the second one. What type of bond is this? 1. So it's number 1. Roman figure 1. You start from here. And Roman figure 2. Check here again. This is 2, right? That's going to be the last one. These are 1s. So it's number 1 and number 2. Propyl, this is 1. What is 1 there? Methanoate. Where do we start from? This side is number 2, right? We go for number one. It's one carbon there. So it's what? Methyl. Then we come to the second part. One, two, three. Pro par noate. Please let me know if naming esters are okay with you now. You must get that thing correct, guys. Must get this thing correct. By force, by fire. By force, by fire. We must get it correct. Okay. All right. All right, guys, I hope this makes sense. Functional isomers, organic compound with the same molecular formula, but different what? Functional groups. Is that okay? Please let's go learn all those definitions. They are very important. Where did we stop? IUPAC name of compound C. Did we do that already? Done. IUPAC name of compound D. Did we answer that already? Done. What is D? Propan 2 on. Already done. Write down the IUPAC name of the functional isomer of D. I thought we wrote it. Did we write it? Okay. D. If we have a ketone, what is the functional isomer? Aldehyde. So this is our ketone. Our ketone looks like this, right? Our ketone looks like this. Ta, 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 ta. When you draw, always use a pencil first. Is that okay? Make sure you count. Don't just draw and leave. But sometimes you might not see it. Yes. The structure, it's fine. Structure, if it's a structure, you can leave it with a pencil. Diagrams, draw with pencils. Is that okay? Okay. Okay, can we then draw the aldehyde? What do? We move this guy to the end. What's it going to be? 1, 2, 3. And what's the name of this compound? Talk to me. Prop, pa, now. I think we did an aldehyde today earlier on, right? Pro, pa, now. What did you write? An aldehyde. Pro, pa, now. Okay. So those little errors will cost marks. Are we okay, everybody? Did that make sense? Is there anything you feel you are not sure of? Please let me know. Because time will not allow us to look at multiple questions. You are the one that will look at multiple questions at home. Huh? Okay. Let me quickly go back to there was that issue on, just going to go back here. Can you re-ask me your question now again? Let's come back here. Please ask me that question again. Right, I get you. It's one statement that I'm going to use to answer you. Pressure deals with gases only. So in this case, there's no gas. All right? Because that's the gas we form there is the product. It's not a reactant. You see, it's not a reversible reaction. Okay. If it's a reversible reaction, then we can say, okay, that pressure there could affect the gas. But this one is a one-way reactant-product reaction. Are we okay there?
Yeah.
All right, beautiful questions. Guys, please let the questions come in. It shows me we are thinking and we are objecting with some things and we're fighting with what we know. And that's learning. All right. Fight with what you know. Quickly here now, let's go for. Oh, we're not done. Let's answer this. I see we're not done. All right. Write down the structural formula of a chain iso. We're going back to that question because we have 4 marks to be completed. Um, okay, guys, I'm going to go back to. Okay, now I can get this. Where's my mouse? Boom. And two, two. Ah, you have those two in your life. You need the police. There we go. Please answer. Can we get this done in 2 minutes? 2.5 minutes. Do it again. Do it again. They're all asking for sweets. We should be done answering this question now, please. But you see the difference. 26 seconds left. All right, let us mark. Write down the structural formula of a chain isomer of compound A. That's butane, right? What would the chain isomer be? Chain isomers are organic compound with the same molecular formula but different what? Chain length. So what are we going to have? 1, 2, 3. Please don't put it on the last one. The last one is still continuous, right? It should be on the second one. Are we together there? So C, H, H, we have that. Does that make sense, guys? What is the name of this compound? What is the name? 2-methyl propane. All right. We should draw compound E. That one is simple now. Compound E, butanoic what? Acid. How many carbon atoms? 4. 1, 2, 3, 4. But because it's butanoic, we have O there, We have OH there. 1, 2, 1, 2, 1, 2, 3. And then we complete. Guys, it is possible to have gotten 19 over 19 in this question. Very possible. Is that okay? Possible to get 19 over what? 19. Are we okay? Okay, guys, are we okay? Quickly, let's look at this. Organic properties. Physical and chemical what? Properties. Let me break this down so that it's big enough for us to see quickly. I see that we can answer 3.1, we can answer 3.2 on its own, and 3.3 on its own. So just to make it clear enough, please, I need the pace. I need the pace. While we are answering this, I'm going to be explaining a few things. All right. 5, 6, 7 marks. Let's answer that in 6 minutes. Everybody, 6 minutes is just too much. Exactly. 5 minutes maximum, please. And this is how you should move in an exam. Come, let's work. Let's work now. Done? Let me know once we say something and you are not clear about. Please, no one should leave with mixed information. Are we done, guys? 2 seconds. Okay. All right, let's check quickly. Guys, I see that some of us are a bit. Let me quickly summarize how to deal with this question very fast. All right, summarize how to deal with this question. We're talking about question number 3. First, you must be able to define the following: temperature, boiling point. What else did we mention? Melting point. And what's the fourth one? Vapor what? Pressure. All right, quickly, guys. What are the factors? I discussed this earlier on today at the other session. Number 1, intermolecular force. Is that fine? And there are 3 of them. What do we have? London. Where do we find them? All. Next one. Dipole, dipole. Where do we find them? All minus hydrocarbons. Next one. Hydrogen bond. Where do we find that? Alcohol. And when it's alcohol, it's one site. Is that fine? Next one. Carboxylic acid. So it's just a very fast crash course. And then what? 2 sides. Is that okay, everybody? Now, to answer this question here, what do? We use the ICE principle. ICE. What does the I stand for? Identify the what? The type of intermolecular force. Number 2, what do? You compare the strength. Compare the what? The strength of the intermolecular what? Forces. And number 3, what do? Talk about the energy required. What? To overcome the intermolecular forces. Is that fine? Then you do your conclusion. That's number 1. Number 2, we talk about chain length, surface area, molecular mass. This reason applies equally. Chain length, surface area, molecular mass. All right. What do we say? Straight chain hydrocarbons, straight chain organic compounds. All right. Have what? A larger surface what? Area. Straight chain organic compounds have what? Larger surface area. What happens with that? There are more points of contact. More points of what? Contact. Of intermolecular what? Force. Net intermolecular force, what happens? Increases. Then can we then conclude that more energy what? Needed. What? To overcome. Answers are just copy. It's a copy and paste system if you get this right. Larger surface, straight chain hydrocarbons have what? larger surface area. Then, then branched one, because we said larger, then branched. These are spherical. That's number 2 there. Its chain organic compounds have larger surface area than the branched one. When it's branched, it becomes what? Spherical. There are more points of contact of intermolecular. Net intermolecular force will increase and more energy is required to come. Makes sense? The last one. Last one will be what? The position. What? Group. However, what I say? You're gonna show? Flames. Love that. Show it flames, papi. Killed you so far. This is the last battle. This is the last battle. Okay. Number 3. Hi. What's number 3 again? Position of what? Of the functional what? Group. Basically applies to what? Alcohols. If the hydroxyl group, is on the first, which is also known as the terminal carbon, hydrogen bond is hydrogen bond is what? Exposed. Strength of the intermolecular more energy is therefore what? Required. Guys, I'm not completing the last statement. You know how to complete that, right? Needed to do what? Overcome the intermolecular what? Force. What happens therefore? Boiling point, melting point. What? High. But vapor pressure. What? Low. This is why, guys, okay, before I conclude here on this one, the hydroxyl group on the inner carbon. An example of this, of the inner carbon. This one, if you check, look at this. 1, 2, 3, and I have my OH there. Carbon number what? 1. That's terminal. As compared to this carbon, what happens? The hydrogen bond, what? Hidden, making the intermolecular force. Blah, 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 blah. Less energy is what? Required. Then propan 1 all will have a higher boiling point than propan 1 all will have a higher boiling point than butane 2 all. Though they have everything in common, same molecular mass, same functional group, blah, blah, blah. The only difference is what? The position of that functional group. If it's on the first, it becomes what? Stronger. Everybody okay there? So those 3 things are your best way of answering. Melting point and boiling point would behave the same way. Vapor pressure will be the opposite. Please do not use the word inversely proportional. Don't get stuck in the exam and say they are inversely what? Proportional. So if I say if melting point increases, what happens? Boiling point will also be high, right? But the vapor pressure, and I think when I was doing this, I did explain what vapor pressure is, right? It's the pressure exerted by the vapor on the liquid in a closed container at equilibrium. Please, let's get those definitions in place. I cannot help with that right now. You've got to fix them. And the good thing is we have expectations of which definitions will be there. Here you'll be tested on 4. Can we take a look at the question now and try to answer? Cannot. All right, let's answer. Let's check quickly. The vapor pressure of 2 organic compounds at a specific temperature are compared. Please also go and check their graph questions. They'll put this in graphs. Remind me to draw a graph for you. Okay. Butane. In fact, let me do that now before I forget. Check what the examiner will do. Examiner will do something like this. And they will do something like this and say this is the atmospheric pressure. Atmospheric. Just drawing, right? And this one becomes the vapor what? Pressure. And this is temperature. They're simply telling you is that this is A and B. What's happening at this point? Where's my circle? What's happening at this point? They're equal. The atmospheric pressure is equal to what? The vapor pressure. So what are we reading there? What is this going to be? The boiling what? Point. Does that make sense to you? The atmospheric pressure and the vapor pressure. Because that's the definition of boiling point. The temperature at which the atmospheric is equal to what? The vapor pressure. Please, is that making sense, guys? So it's just application of what you know already. Good. We want to block every way they want to, attack you. Tomorrow is Monday is the final one. Whoever wins that wins the game. Jury time on Monday. This is when we score. We play 0-0. When it's almost the end, sharper goal. And we tell the referee. All right, let's quickly check. All right, now let's compare this quickly. What do we have? We have butane and propane. Now listen, butane and propane. What do you think is common there? NA, right? Which means homologous what? Series. That is my controlled what? Variable. Whatever is kept constant, it's a controlled variable. Another controlled variable is this. See that those are also constant, right? So if they ask you for controlled variable, we can say homologous series or what? The molar mass. Why do we need controlled variable? To make the experiment fair. I saw something there. Give a reason why they are both is considered fair. fact, we have two of them. They have the same molecular mass and they belong to the same what? Homologous series, or they have the same functional group. Yes, yeah. Control variable is there to make the experiment what? Fair. It's there to make the experiment what? Fair. Someone is raising a hand. All right, but if you are saying molecular formula, you're not very direct. Just say homologous series. Okay? Say homologous series. It's preferable to say that. Are we okay, Frederick? Tabs, talk to me. Yes, they do. That's why the molar mass is the same. The number, they have the same number. But if you just say they have the same number of carbon atoms, I don't think it's enough. Because what if I have butene? See that the number of carbon atoms is still the same, right? So let's look at something that would make it completely fair to compare both of them. Is that okay? So I would really prefer us to say they are homologous series. Homologous series with the same molecular mass. Are we okay, everybody? Frederick, are we fine? Okay, good. I saw your response. All right. Guys, what is the independent variable? What are we changing? Changing the chain length. The first one is what? 4 carbons on a straight chain. Second one is what? 3, because it's what? Prop. So our independent variable is what? Chain length. Independent is what it starts with the letter I. What am I changing? Is that okay? I am changing the chain length. Therefore, the chain length becomes what? The independent variable. What is the dependent variable? Like if you are paying attention to what's written on the board. Vapor pressure. Because the vapor pressure depends on the chain length. Make sense? Are we together? Lovely. So, don't you think we've answered all of this? Which one would have the highest boiling point? A, it's butane. Highest boiling point. Relax. The question says higher vapor pressure. Calm down. Okay. Then which one would have a higher boiling? Okay. Which one has because that's the way to get the answer. You start from boiling point. Which one has the higher boiling point? This one has what? A high what? Boiling point. Why? Straight chain. Larger surface what? Area. More point of contact of forces. More energy is required to overcome. Boiling point. Check. It's a memo. This one is the one. Okay. What about this one? Low what? Boiling point. And automatically we know that we switch it when it comes to what? Vapor pressure. Does that make sense? So which of the two compound has the what? Highest vapor pressure? What will it be? B. Fully explain your answer. Ice. But in order, this one, we're now saying identify. We already know. But here you are going to be using your what? Instead of saying ice, just ice alone, you are going to be using your chain what? Length. Does that make sense? Already answered, guys. We spoke about it. The longer the chain length, the bigger the surface area. Is that making sense? All right, so you answer that. Talk about chain length. The chain length of butane. Butane is what? longer than what? Methyl propane. So it has a larger what? Surface area. Then methyl propane. Net intermolecular force in butane is what? Stronger than methyl propane. More energy is required to overcome. Go the route of vapor boiling point. Only at the end you just change your answer. Everything remains the same. More energy is required to overcome the what? Intermolecular force in butane. Therefore, instead of now saying boiling point, what do you say? The vapor what? If you like, if you are confused, you can even start with boiling point and change the answer to say butane will have a higher what? Boiling point, therefore a low vapor pressure. You done. Same story, same story. Chemistry is in trouble. I can feel it. All right, quickly, guys. Let's answer 3.2. 3.2. I need you to be, guys, we don't want to waste time here. This should be done very fast because I have actually answered all of these things. All these answers have been given to you. You just need to find them. Bring that job. Guys, eight marks here. I'll make it six. Answer as if this is an exam. Give me the full answer. We are going to mark. Let's answer this question. All right, quickly, let's run. Let's answer. The compounds propan one all and propanol. Okay, guys, what are we comparing quickly? Propan one all is what? Alcohol. Propanol is what? Ketones. This is just ice here, guys. Identify, compare, energy. I'm not writing anything, so please listen. Can we identify? In propan one all, what do we have? Alcohols. Okay, let me show you how to write this answer. Because here, Busolo says he's been writing essays. And I don't know what essays is here. Look at how I will answer this question in an exam if I were you. But I'm not you. So, when you are going to write how Mandela brought propan one all and thought, no, there's no need for all of that. Guys, let's look at my write-up. I know I am using what? Ice. Is that fine? So I'll come with my first bullet. What is that? Identification. I'll just say propan one what? All has what? One side of hydrogen what? Bond. What's next? Propanon has what? Dipole. Dipole. I am done with my first bullet. Identification is done. What's next? Compare. Is it making sense? Compare. What do I say? The hydrogen bond. So don't let's write stories. The hydrogen bond in propan, because we must specify where it is. One all is what? Stronger than the dipole, dipole, all right, in what? Propanol. I am done. Propanon. I am done. Number 3. Is it making sense, guys? The energy required is even a big word. It's too long. Needed. What? Don't write IMF. Overcome the hydrogen bond in what? And one all. What? Higher than energy needed, or energy. You can even say energy for. Cut it down. For what? No. For dipole what? Dipole in propanon. Therefore, the boiling point of propan one all is what? Higher than, you don't even need to write the boiling point of that. Then that, let's use English. That of what? Propanon. Oh, 4 marks. That's a memo. That therefore you don't even need it. Just a bullet. Yes. Okay, guys, I've got a comment here, and I'm going to tell you what it's been said so that you also learn. Yes. But which sentence? 1, 2, 3. Bullet what? Point 2. Say what? Yep. Not really, because we are comparing. Every time we are comparing, we must talk about 2 things. Like, I can't tell you now that I'm darker or I'm lighter. If I say I'm lighter, won't you say then? Then who? And I know in this place I'm lighter than some people. once I say stronger, what's funny, guys? Because I said I'm lighter. It's a fact, guys. To some people, I'm a white man. It's bullying. Okay, sorry. I didn't mean to bully. It's personal. But guys, did this make sense? And the layout. So we're not writing too many stories. We're going straight to the point. We get the answer and we're done. Make sense, everybody? ICE. Identify, compare, talk about the energy, and make it what? Even if they want vapor pressure, I still answer the same way. I can now even say the last point. What happened? I switched the vapor pressure stuff. Right. Quickly, the last one. 3.3. Yes, Steps, talk to me. Yes. It's important that you mention the two because you are going to be comparing those two. Okay, oh, all right, I get that. Here, you don't really need that. Here, you don't really need that because we're looking at the one that is most prominent. All right, the table shows the result of investigation regarding um, the melting point of organic compounds. Quickly check. It says the melting point, but they wrote boiling point here. Gosh. But it's fine. Melting point and boiling point have the same trend, right? So change this to what? Melting. All right, write down the independent variable. What are we changing? Check, please quickly check. What are we changing? What is the difference between all of this? Chain length. Write down the independent. What are we changing? Right. Okay. They should have after this question. This question is a bit faulty because we should be comparing. We could have compared A and B. So it's a bit faulty. But let's try to find an answer because A and B, what we are changing is different from what we are changing when we bring in number three. But okay. If I look at A and B, what am I changing? The post have different what? Boiling points there. And what about C? If I bring in C, what am I changing? I'm actually changing the chain length. So the comparison is not okay. All right. However, yes. What are we changing? Because I see here the you see I would have even if they had said what is the controlled variable, that one is still even answerable. The mass is still the same in all of this. Logos series is still what? The same. The fact that if I compare A and B, I'm changing something different. If I compare B and C, I'm changing some prelim papers. They have all of this funny. Explain the trend in the boiling point. What's the trend? You see, already, the reason why I said the question had the flow, it's regarding the melting. They gave us table on what? Boiling. Now they are asking for boiling, but the instruction says melting. But we're just trying to understand what's going on. Is that okay? Yes? By us, I add extra carbons. For example, okay, the question is when does molecular mass change? If I look at methane, CH4, right? If I then go to the next compound, methane, C2H6, The mass has changed because I've added more carbons and more hydrogen. But in this case, I promise you, if I were to answer this in an exam like this, what is the independent answer this, you don't know chemistry. But you understand why I'm saying there's a flaw? Because whatever I'm changing here is different from what I'm changing there. And basically, also, the examiner is also trying to look at isomers. Is that okay? But the first two talks about what? Positional isomers. The last two talks about what? Chain isomers. Do you see the conflict? Explain the trend and the boiling point. Now I would use my what? They're supposed to either compare A and B or B and C. I would like to check what the memo is saying. All right, guys, are we okay with our answers? So let's just, guys, here's the deal in chemistry. I want you to quickly note this. Cannot compare at a time more than one. Cannot compare more than one variable at a time. Compare two variables. The experiment. For investigations, you can only compare what? Organic reactions. This is very, if you followed my lesson, this is one of the simplest ever followed my lesson. For those that, you don't need to write, you just take a picture of this and listen carefully. Listen carefully. I'm going to use about 5 minutes to answer all of these questions. Say what? Saturated, substitute. You all know that. Okay? So that, if it's sat, it is what? Sub. Saturated, unsaturated, elimination. All right. What's next? Saturated, addition reaction. Please don't forget. Strong acid or base. What are we doing? Elimination. Dilute, strong. Let's stick to base. We use that more. What is this? But for elimination, what do we need? Strong heat. Mild heat. Reaction and catalyst. When it comes to hydrogenation, platinum or nickel. When it comes to halogenation or sunlight. When it comes to addition, and I'm going to be specific here, alkene produce what? Alcohol. I'll be using phosphoric acid or sulfuric what acid. But this is most preferred. Then I'm putting all my answers in one page. You would see that this page has all your answers. I talk about combustion. What do we know? Alkane plus oxygen would give us what? carbon dioxide, and water. Not just alkane though, alkenes, alkynes, but they don't really test on this, even alcohols. All of this would have the same effect, but mostly alkanes is the one that is most what? Tested. Are we okay, everybody? Finally, here is to talk about what? Cracking. And there are two types of cracking: thermal and catalytic. Thermal, what do we need? High what? Heat and high pressure. Because heat thermal means heat. Catalytic, we use what? What are we breaking down? We usually break down an alkane. Options: A smaller alkane plus an alkene. B, an alkene plus an alkene plus hydrogen. You know this thing that I've written? That 15 marks, it's yours. Done already. I want to take a picture, but this. Okay, they'll send it on the group. Guys, those of you that have taught and you've seen this, you know that this has all your answers. Or like literally almost all, if not all. All right, guys, so this is my organic reaction sorted. Okay, let's go check if we can use this note to answer the question. So, I'm sure you all have pictures now. Let's see quickly here. Let me try to do something here very fast. So, guys, what will happen is after this, we can quickly touch on what? Because time would be almost gone. I would see. I really want to do some stoichiometry. All right, quickly check this, everybody. Now, CH3, CH2, CH3. Is that saturated or unsaturated? Sorry? We just need to check. How many carbon atoms? 3. How many hydrogen atoms? 8. So 3 times 2, 6. Plus 2, 8. If you are not sure, draw. H3, CH2, CH3. Do we agree that it's saturated now? All right. What? Satu. Oh, by the way, please don't forget this. The bromine test. Guys, everyone in this class is on the group, right? One or two groups. I sent you a small video today on bromine. Unsaturated will do what? Decolorize bromine water. So unsaturated decolorizes. Colorizes what? Brown bromine water. So I sent that little experiment. It explains everything, and you'll remember. All right. Everyone must have seen that. Please check. I sent it around what time? Around 3 or so, somewhere there. Okay. Guys, do we agree it's saturated? What are we doing? We are now adding what? Br. Can you see Br today? Going to compound what? A. This is saturated. We are adding Br. What's going to happen? It's substitution. So we have that. Plus what? Br. We are going to have it what? We are going to have it as, no, it's Br2. Is that okay? So we are going to have it as what? A substitution what? Reaction. Are we okay there? Substitution reaction. So what are we going to have here? This also will be what? Saturated. So this reaction is what? Substitution. They are telling us this is what? A secondary what? Alcohol. I want to show you something very tricky on this question. Secondary what? Alcohol. Alcohols are also what? Saturated. Are you with me? What type of reaction is this? Substitution. By the way, you must know the difference between hydration and hydrolysis. Hydration is an addition reaction. Let's just put it somewhere. Hydration is an addition reaction. Keep taking pictures. Hydration is what? Addition. And hydrolysis. What? Substitution. And you do know your conditions for check. This one here is my hydration. That's my hydration there. And I know the condition for substitution. What do I need? Strong base. Let's example. Let's just stick to one. Okay. Let's see quickly. We have what? Saturated to saturate. But here's what I wanted to see. Do you notice the examiner is giving you a clue? Watch this. What are we forming? A secondary alcohol. Can we draw that secondary alcohol? What are we going to have? COH. I don't want you to jump into this thing. Guys, are you with me here? Secondary what? Alcohol. Now, what is in between the two? Compound what? A. It means I am replacing this guy. What should I then have? A secondary what? Haloalkane. So the examiner was actually substituting only one what? Bromine. That makes sense. If I say plus Br, I am going to be getting this plus HBr. Does that make sense? I only substituted one because I see that the examiner wanted one to be substituted to get what? A secondary what? Alcohol. Did that make sense to you? That make sense? Okay. Now, from here to here, what should I be using? That it's what? Substitute. What is the condition? Dilute sodium hydroxide. So this is plus dilute what? Sodium hydroxide and mild what? Heat. That makes sense to you guys? Now check what's happening. This OH is going here. What happens to this Br? It takes the place of what? Na. So what do I have? Plus NaBr. Guys, just draw. That's the whole thing. Draw and play your games right. Don't play chiefs to win. Please. Hey. No, we're in the same boat. Don't worry. I'm consoling us. When you talk about it, you laugh about it, the pain goes away. Okay. But we will not go back from the yellow. I can't follow skeletons. Okay. Just saying. No life there. Whichever way you want to take it, Nanta Abamina. All right, please check. I just want us to look at this whole structure before we even answer the question. Are we okay with alcohol there? Now, wait, I am seeing something here. And they're telling me, hold on, this is what? Unsaturated. From saturated to unsaturated, what am I doing? I am eliminating. Elimination, right? This is why I want you to go back to my answer. What is this? Sulfuric what? Acid. This is why I said for elimination, what do we use? Strong acid or base, and it must be concentrated. This is not just sulfuric acid. It is what? Concentrated sulfuric what? Is it making sense to you? Now check. Saturated to unsaturated. You see they bringing in this. But what type of sodium hydroxide is that? Saturated to unsaturated is what? Elimination. So what are we bringing in? Concentrated. And what? Strong what? Heat. Guys, is it I don't know if it's making sense to you. Making sense. Guys, all you need to, I beg, if you are struggling, just study this thing. Study it, read it, try to write it down on your own. Everything here. Once you get this right, boom, 15 marks is in the bag. We just applying now. Is that okay? We just applying. But I want us to write this compound A plus sodium hydroxide to form an alkene. What's our compound A? And with the bromine, right? Okay. Because I want us to apply Markovnikov's and that other rule. 1, 2, 3. We have what? Br. H. We have H there. H. Everybody? Okay. Plus what? Concentrated what? Sodium hydroxide. In the presence of what? Strong what? Heat. Are you with me there, everybody? What are we doing? Since I say concentrated, we are removing, eliminating. Can we eliminate this gentleman? The next one is, which hydrogen do we eliminate? Please, I have seen learners eliminate this one too. Guys, right leg. Can you please leave him with the left one to be able to hop? You are beating them 1-0. Then the referee gives them red card again. Boom. Eish. Can the referee just pity them? So guys, we don't remove that hydrogen there. Which hydrogen do we remove? We check the ones on the next. It's either going to be from here or from here. But since we are removing, what do we say? The pore gets poorer. We count. How many hydrogens do we have on the left? 3. How many do we have on the right? 3. We can remove from any. Isometric substance. Iso simply means it's the same on the left and the same on the right. So can we remove this one? What are we going to form then? 1, 2, 3. 1, 2, 3. 1, 2. That. So something is missing. Double. Once you draw and you know the conditions, you know your expectations. Are we okay? Have you answered? Welcome to Lens. All right, write down the type of reaction that takes place. X, did we answer it? Elimination. Y, substitution. Z, elimination. Because it's saturated to unsaturated. Guys, you're writing more. Just let's look up. Reaction X. Okay. Reaction X. Let me quickly. I'd have actually answered everything though. Reaction X takes place in the presence of what? A strong base. Write down the IUPAC name of A. Did we do A? The IUPAC name of A. 2-bromopropane. This is our A. Please enjoy this section. Enjoy it. That's A. 2-bromo what? Propane. Next, balanced formula for the reaction X using structural formula. Balanced formula for the reaction of X. Which is reaction X? The one with sodium hydroxide, right? Oh, that's my answer. But this one is in. What did we remove? HBr, right? But take note, I removed HBr, which is a base. But then I have what? HBr, which is what? An acid. But then I have what? NaOH, which is a base. What are you expecting? So, makes sense. So what am I expecting? Yes. Hence, we are going to have what? HBr plus H2O, right? When they say draw the structure, your water must be written like that. Huh? Between? Oh, yeah, since it's structure, that. So please take note of what goes on here. I get rid of HBr, but immediately HBr sees that there's a base. There's what? A neutralization reaction. Yes? Oh, yeah, NaBr. Since I used HBr there, right? Thank you. NaBr. That is my salt, sodium bromide. Plus what? H2O. You get your 4 marks there. Is it making sense? The whole idea is learning how to draw. So once I remove, I consider HBr plus NaOH. Acid plus base will give us what? Salt and water. That's my salt and that's my water. All right, guys, are we okay? IUPAC name of the alkene formed. What's that alkene? Group? It cannot be one. Group? One what? In. This double bond is in between carbon number 1 and carbon number 2. It goes always for the smaller number. Say 2 differences in reaction X and Y. Aha, check. Whoever said this thing is not working. Reaction X and Y. X is what? Elimination. Y is what? What are the differences? And strong heat. For substitution, I use what? Dilute and what? Mild heat. Whoever said this thing is not working? Disclaimer: this thing is developed by crazy physics. Yeah, we just put the disclaimer very bold. But guys, do you see that all our answers, I kept coming back here? It's all in here. It's all in here. One more or 2 for the last one. Compound B is a secondary what? Alcohol. Define the term secondary alcohol. Pregnant woman. H. What do we say? The carbon atom. We're still reading dash dash. Attached to the hydroxyl. Stop going back to that note. Hydroxyl group is attached to what? 2 carbon atoms. Back to the notes to check. You're shutting off your steps. Talk to me. Yes, you can write propane, but don't get used to writing without the number. Because if you get used to writing without that number, you might forget on other compounds. So you rather stick to that which will be marked correct all the time. Is what I'm saying making sense? So that you don't make a mistake. For example, if you write butanol, it's wrong. I just wanted to stick to that system, know that, okay, something is missing, the number is missing. Although in this case, propene is actually very correct because there can only be one thing here. There cannot be prop 2. It will always be what? Prop 1. But just to keep you in that loop of saying the number. Right. But good observation there. Guys, 15 marks is done. And where did the answer come from? That came from here. It is important for us to revise empirical formula. 11. Okay, yes, it's grade 10. All right, let me quickly do something. I'm going to do percentage composition and empirical formula. Percentage what? Composition. Yes, Nana? Percentage composition. Um, da-da-da-da-da. Give me. I want an organic compound. Give me the formula for butanoic acid. That right? Are we okay there? How many carbon atoms? 4. How many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8. How many oxygen atoms? 2. Huh? Oh, okay. Percentage composition. Guys, please quickly calculate the molar mass of this for me. You all have periodic tables. You have 30 seconds, maximum 45. And there's a question I'm going to look for. There's a nice one, May, June this year. Very nice. You have one there? Okay, I'll find it. Please, somebody just remind me. 88. Did you calculate it? Do we have 88? Carbon is what? 12. So this is what? 12 times 4 plus 1 times 8 plus 16 times 2. That's what? All right. Now, percentage composition. This is what the examiners do now. Percentage of carbon. This is carbon, right? This is hydrogen. This will give us what? 48. This will give us what? 8. And this will give us what? 32. So they'll say 48 over 88 multiplied by 100. Somebody give me an answer. 54, comma, 54. So, comma. All right. 8 times 100 over 11, or 8 over 88, which is 1 over 11, right? 9, comma, 0.9%. And then percentage of what? Oxygen is what? 32 over 88 multiplied by what? 100. What would this give us? Comma? 36. All right. That's how we do percentage composition. Now they create the question now. Now they will give it a percentage composition and they want you to get what? The molecular or empirical. Let's quickly, what's the difference between empirical and molecular? Empirical what? All right, empirical formula. Thank you, tutor. Somebody's reading. A formula that shows the what? The simplest, please take note, whole what? Number ratio of what? Atoms in a compound. What about the molecular formula? The formula that shows the exact number. I need to find that question. There's a beautiful one. Of atoms. I'll look for it. We'll deal with it tomorrow. But if you can lay your hands on it, May, June 2023. It was a beautiful one. Right. Formula that shows the exact number of what? Atoms. So an examiner would give you this ratio. Carbon, hydrogen, and what? Oxygen. Because what I noticed is that there's a lot of grade 11 stuff this year. Monday, I'm saying this live on YouTube. Accident, that's what's coming out. Live. Quote me. I'm joking, guys. I'm darling. But I have a strong inclination that percentage purity, so it's something we need to check. Is that okay? But I'll be dealing with that tomorrow. All right. Formula that shows the exact number of what? Atom. Your heart gives. Okay, guys. Do you have these percentages for me? You have them? Okay. I'm moving now quickly. All right. So this is what we'll do. Carbon, hydrogen, and what? Oxygen. What is this? 54, what? 55. What was hydrogen? 9,09. And oxygen? Now, sometimes they may not even give you that oxygen. What do you need to do? You add and subtract from 100 because it's all what? A percentage. Now, please make sure you get the percentage. The percentage is then converted to what? To mass. Now, atomic mass. Carbon is what? 12. Hydrogen is what? 1. Oxygen is what? 16. Are you with me there? What do we find? N. Mass over molar mass. What do we have here? 54,55 divided by 12. Somebody who's kind enough can start working that out. Okay, 1 second. Over what? 1. 36,36. Yes, first one. 4,55. Somebody's working on the last one for me already. 9,09. And then last one. Sorry? What? 27. Now what do? You find the ratio. How do you find the ratio? Divide by the smallest. So ratio, divide by the smallest. Which one is the smallest? So 4,55 divided by what? 2,27. What's next? 9,09 divided by what? 2,27. What's next? 7 divided by what? 2,27. What do we have? 4. This is an empirical what? formula. What do we write? C2H4O. Hold on. Let's go to the formula we started from. C4H8O2. Divide everything by 2. What do you get? 2, 1. That is empirical ratio. Now they will then give you the molecular mass. The molecular mass is 88 grams per mole. Determine the molecular what? Formula. Determine the molecular what? Formula. This is what I'll do. I'll look for the ratio. And molecular mass over empirical mass. Molecular mass over what? Empirical mass. What is this? This is what? Because it is a ratio. Now, what is the molecular mass? We are given that as what? 88. What is the empirical mass? We take that thing there and calculate C2H4O. 44. Are we okay with the 44? Because we are saying here is what? 12 times 2 plus 1 times 4 plus what? 16. That gives me what? 2. What do I do with that 2? I multiply the empirical formula by what? By 2. So my molecular formula then becomes what? 2 times 2, 4. 4 times 2, 8. 1 times 2, 2. So we've gone full cycle now. But I need us to look for that. I'm going to look for that one and please just remind me, because it had some 2 grams and whatnot. There's a bit of some things. Please let me know if this is okay. This is grade 10, done in 2 minutes. Is it okay, guys? Is it okay? All right, guys. We have 15 minutes, but let's make it worth. Let's make it count. Is that okay? Let's look for something we can quickly do in that 15 minutes. I'm going to teach you the table. Relax. Guys, do you think we can answer this? Quickly, we can answer this. We'll answer it together. Let's just do, okay, no, wait. I'm changing my mind. I'm changing my mind. Yeah, because you guys were complaining. And when you complain, when you are complaining, no. This one is more okay. Yeah, this one has less marks and we don't have time. See, it makes sense. This is 11. What about 9.4? Yeah, so. You guys are just joking. Yeah, you're lolling. dwelling too much. You're dwelling in excess. You're dwelling in excess. All right, guys, quickly. The first thing I want to see here is what? This is what? An electrolytic what? Cell. Please quickly, what do we know about electrolytic cell? Just before we answer this, let's talk 5 minutes or less. Number one, it is what? Non-spontaneous. Is that okay? Number two, we use what? A DC power supply. Is that fine? Why? To maintain what? Polarity. Maintain polarity of electrodes. Guys, I want to see if I can stop at the exact time. To maintain polarity of what? Electrodes. Is that okay? What are we doing? We are converting what type of energy? Electrical energy to what? To chemical energy. What I needed to know here quickly is we are using the acronym APE. What does APE stand for? The anode is positive in the electrolytic. Please, I don't know, anybody that has the note on how to identify anode and cathode, please take a picture. There are 10 ways. I gave you 8. I added 2 to it. I upgraded that note. It's now 10. All right. I'll check on it. But let's quickly focus on this quickly, everybody. What are we doing? We are refining what? Copper. Guys, I am interested in 9.4. All these other things, we can get them. Refining of what? Copper. Is that okay? If we are refining, it means it is impure. Take note. I'm going to say a lot of things here quickly on this board. Impure. Which one is the anode? This. Because anode is what? Positive. The negative is the cathode. This one would be what? Pure copper. And this one is what? Impure. So please take note. The impure is at the anode. And the pure is at the cathode. We want to see pure copper at the cathode. We see at C. You remember that statement? We see. SWE. We SWE, right? We see. At where? At C. What does C stand for? The cathode. So we want to see pure copper. Where would that be? At the cathode. We see at the cathode. Make sense, everybody? Lovely. What are we going to have here? Copper what? 2+. Because everything we are dealing with is with copper. All right. It's a definition. Think you are done there. All right. Everyone in this place should be having to have heard those songs by now. Write down the formula of the cation. I am done. Cu 2+. When an electric current passes through the electrolyte, the mass of the electrode what? Changes. Which one increases, by the way? The cathode will increase in size. I used to humorously talk about a pregnant woman. What happens to the shape of the stomach? It's a C. What happens to the weight of the pregnant woman? Increases. So the cathode will what? Increase in size, while this one will what? Decrease. Okay, can we answer this question? 9.3.1 and 2. Does the mass of X increase or decrease? Decrease. Because it is the anode. Write down the relevant equation. Look, very simple here. Very, very straightforward. If it is decreasing, this is what I wanted to see. We are starting from a solid. I'll repeat. If it is decreasing, you start from a solid to aqueous. If it is increasing, you start from aqueous to solid. Basically, this is what I'm saying. Solid is something I can see. Aqueous is something I cannot see. So if I am moving from something I can see, let's look at something. Let's put a box of pizza. It's solid. Can we see it? Yes. When you eating it, what's happening to that space? It's becoming aqueous, invisible. What's happening to the weight of the pizza? Decreasing. Does that make sense? Because I know you can picture food. Some of you are actually tasting the thing right now. I can see two is like. All right, so what's happening? We are saying this one is what? Decreasing. So we must be starting from what? A solid to what? To an aqueous. So what are we going to have? Copper solid to give us what? Cu2 plus, which is what? Aqueous plus 2E. Ooh, with time. 9.4. I have taught you stoichiometry. Are 3 steps to this. Step 1, find the number of moles that reacted. Number 2, mole ratio. Number 3, calculate the number of moles that. It is always like that. So I don't know why you guys are saying, number 4. Guys, those 3 steps are there. Is that okay? And I'll quickly show you the 3 steps. It says, during the process illustrated by the above cell, a total of 2,259 times 10 to the power 24 electrons is transferred. That is the number of electrons transferred, not the number of moles. Now, calculate the mass change at the cathode. Can we write the half reaction at the cathode? It is plus what? 2E to give us what? Cu. Please check. What are we looking for? Mass at the cathode. How do you get mass? Number of moles is mass over what don't you have? Number of moles. But they gave me information about what? Electrons. So I am going to be using electrons. Does that make sense? What do I know about electrons? I know the number of electrons. What is the number of electrons that I have? 259. 2,259 times 10 to the power what? 24. But I need to convert this into what? Number of moles. Number of moles dash N over Na. 259. It's there on the formula page. Somebody's pressing the calculator for me. 6,023 times 10 to the power 23. Quickly, guys, quickly. We have 2 minutes. 2 minutes. And we need to finish. What's your answer? 3,75. Moles of what? Of the electron. I am done with my step 1. Did you get that? Step 1, you calculate the number of moles that what? Reacted. Are we okay there? Step number 2, what do I use? Mole what? Ratio. E and what? Copper. How many moles of electrons? 2. How many moles of copper? 1. But how many moles of electron do I have according to the reaction now? 3,75. And that will be what? N. Can we cross multiply? What do we have? 2N equals to what? 3,75. What is N? Round up. Thank you. 875 moles. That is the number of moles of what? Copper. Do you notice I'm back here now? So number of moles is what? Mass over molar mass. Oh, let me do this. Number of moles of copper. Do I know the number of moles? 1,875 equals to mass over copper is what? 63,5, I think. 5 marks is done. 100 what? Are you sure? 0.06 gram. Exactly 9 o'clock. Guys, That is your stoichiometry. You will do under rate of reaction again. Same thing. Step 1, number of moles that reacted. Step 2, mole ratio. Step 3, calculate what you need. Who doesn't have those steps? Have them. Get them. Step 1, calculate the number of moles that reacted. Step 2, mole what? Ratio. Step 3, calculate what you need, because everything you need is surrounded around number of what? Moles. 119,08, you are giving me 119,06, or at least. Okay, guys, in the exam, you write what your calculator gives you. All right, guys, good night. Please, let's do some work again today. So tomorrow, what are we doing? Acid and base, chemical equilibrium, and a bit of what? More electrochemistry. And we're done, guys. Please use the prelim revisions as a guide for yourselves. It will assist you. It's a lot of work, but we have to pay the price. All right. Have a lovely evening, everybody, and God bless.